Let's consider the domain and range of different relations and functions that we'll encounter throughout algebra. First, looking at a table of values, it's very easy to give the domain and range from a set of points or a table of values because it's all listed for you, right? The domain is the x values 1, 2, 3, and 4. So I can just list those as a set for the domain. The range is the y values. It's 3, 5, and -4. I can order those and list them as a set for the range. Notice that I'm not repeating the value of 3. I also want to point out that this example is a function. There is a repeated value, but it's a range value. Remember that our test for the definition of a function is, does every domain value match with only one range value? And that's true. 1 matches with 3, only with 3. 2 matches with 5. 3 matches with -4. 4 matches with 3. Now that happens to be the same range value as 1 matched with, but that's okay in terms of the range. What's important is that every domain value only has 1 matching with 1 range value. It's okay if they go to the same range value. So this is a function, and here's the domain and the range. Second example, this is not a function. It violates the vertical line test, but we can still give a domain and a range for this relation. On a graph, the domain is the x values. It's measured on this horizontal axis, and you think from the left to the right. The range is the y values measured on the vertical axis from the bottom to the top. And so we want to know what are the largest and smallest x values and what are the largest and smallest y values of this graph, and that defines our domain. Here the domain and the range are intervals. It's a whole range of numbers in between the largest and smallest ones. So I'm going to start with these endpoints, beginning with the domain. The smallest x value is -3. Moving from left to right, it includes all the x values up to +3. In interval notation, I write that as -3, +3, with brackets around it. That means the endpoints, -3 and +3, are included. And this represents the whole interval. It's everything in between these points as well. The range is similar, but when I report the range, I think from the bottom of this picture to the top of this picture. What's the smallest y value and what's the largest y value? The smallest y value is -1. The largest y value is +1. So our range goes from -1 to +1. Again, with brackets. You'll see lots of linear functions in algebra, like number 3, y = x + 2. What's the domain and range of a linear function? Well, look at the graph. Think the domain is all the x values from the left to the right. The range is all the y values from the bottom to the top. This graph extends infinitely in this direction and in this direction. So the domain of this graph is all real numbers, or in interval notation, we say it goes from -infinity to +infinity. If you go all the way to the left on this graph, there will be an x value on the line. If you go all the way to the right, no matter how far you go, there will be an x value on the line. So the domain is from -infinity to +infinity. The range is also from -infinity to +infinity. That's true for almost all linear functions. The only exceptions would be a horizontal line and a vertical line, which is a line but not a function. We'll talk about that later. What about quadratic equations? Here's a basic one, y = x². What's the domain and range? Again, we'll look at the graph. The domain is the x values from the left to the right. Here, these lines keep going upward and outward. So no matter how far I go to the left, I can find an x value that's somewhere on this parabola. No matter how far I go to the right, I can trace it up to the parabola and find a point on that parabola. So my domain is from -infinity to positive infinity. That's true for all quadratic functions. What's the range? Well, the range is limited here because the range is the y values from the bottom to the top. The smallest y value we see for this quadratic equation is at 0. So the range begins at 0 and it goes to positive infinity. The lines start at 0 and they extend upward infinitely. I want to consider one more question. This is a rational function, y equals x plus 5, and I didn't draw the graph of that because it's beyond the scope of what we're going to discuss here. But I want us to remember one thing. Let's talk about the domain of this graph. Division by 0 is undefined. So when I think about this equation, I could consider plugging in different x values and I get an output value by evaluating the x value in this equation. There's one x value that's going to cause trouble though, and it's the x value that causes this denominator to equal 0. Division by 0 is undefined in mathematics. So I can find that problem spot by taking the denominator and I'm saying this denominator is not allowed to equal 0. X plus 5 does not equal 0. That means if I subtract 5 from both sides, x cannot equal negative 5. X does not equal negative 5. It could be anything else, but if it equaled negative 5, then that denominator would be 0 and this expression would be undefined. So my domain here is all the x values except for negative 5. How do I put that in interval notation? That's a little more complicated. I could consider a number line from the left to the right, and I want to include all the x values except for negative 5. So my domain would begin at negative infinity. I could include any x value up to negative 5, but not including negative 5. Skip over negative 5 and include any domain value, x value, larger than negative 5. So my domain ends up having two parts, two intervals to it. It's from negative infinity to negative 5, and it's from negative 5 to infinity.